Welcome back. The objective of this video is to do a couple sample problems involving geometric sequences. Here in example 13, we see that Tim released a helium-filled balloon that rose 200 feet in the first minute. In each succeeding minute, the balloon rises 50% as far as it rose in the previous minute. 50% is 1/2. They want us to write a general formula, A sub n, that gives the number of feet risen during the nth minute of the balloon for airtime. So our A sub n equals, well, 200 is how far we rose in the first minute, so that is our A value, and the 1/2 is our B value. So we have 200 times 1/2. So if it rose 200 in the first minute, if we put 1 in for x, well, we'll have to do n minus 1 as we've been doing, and that is our general formula, A sub n. If I put 1 in, I get 1/2 to the 0 power, and sure enough, I get 200. So then use the formula to find the height of the balloon reaches after 8 minutes. So A sub 8 would equal 200 times 1/2 raised to the 8 minus 1. 200 times 1/2 raised to the 7th power. And 1/2 to the 7th power is 128. So A sub 8 equals 200 over 128, which simplifies to 1.5625. If we want to complete our table, we can just keep going in halves. 200, 100, 50, 25, 25 halves, 25 fourths, 25 eighths, and 25 sixteenths would be the easiest way to do it for me. In example 14, we've got Big Tech Electronics advertises a monthly payment plan for the purchase of the best-selling tablet. Buyers pay $50 at the end of the first month, $55 at the end of the second month, $60.50 at the end of the third month, and so on for 1 year. What will be the payments at the end of the 4th, 6th, and 10th months? Well, let's figure out what our R is here, and then we can come up with a formula to figure out and answer those questions. Writing this out in table form, I see that after 1 month it's 50, after 2 months it's 55, after 3 months it's 60.5. We might see here that this is a 10% increase each month. So our R value here then is 1.1, our 10% increase. So our formula, A sub n, will equal 50 times 1.1 raised to the n minus 1. That then gives us A sub 4 equals 50 to the 1.1 raised to the 4 minus 1. And A sub 6 equals 50 times 1.1 to the 6 minus 1. And A sub 10 equals 50 times 1.1 to the 10 minus 1. And reaching for our calculator, I will then get $66.55 for A sub 4, and A sub 6 is equal to $80.53, and A sub 10 is equal to $117.90. In question B, it says, how much will a customer pay for the tablet with this payment plan? Well, we're paying for an entire year, so we need to figure out all 12 months of the payment plan. So it looks like we'll add all these together, so our total is going to be a sub 1 plus a sub 2. We're getting a little preview here of a summation of all of these through a sub 12. So we're looking at 50 plus 55 plus 60.5. We said a sub 4 was $66.55, plus a sub 5 plus a sub 6 was $80.53, plus a sub 7 plus a sub 8 plus a sub 9 plus a sub 10 was $117.90, plus a sub 11 plus a sub 12. So we're going to have to go back and use our formula and find out what all these particular values are. So once I find all those values, a sub 5 would be 1.1 raised to the 4th times 50, and a sub 7 would be 1.1 raised to the 6th times 50, and so forth. I've filled all those out in blue, and my total cost would be $1,069.21. So as I just mentioned, our general formula then would be a sub n equals 50 times 1.1 raised to the n minus 1. So that's the formula I use to find the 7320 and the 8858 and all those other values. Now we could also put this in function notation, and so that means we're going to use like the 0th month. So it ends up being 50 divided by 11 raised to the 1.1. Now instead of n minus 1, it's raised to the n, because that's the dividing 11 is going to give us the previous value to the $50. Finally, what does the ratio represent in context of the scenario? Well, you're paying a 10% increase each month. So you could say you're paying 10% additional each month, or 10% interest on your balance each month. So that wraps up a couple sample problems with geometric sequences, and we'll get some more practice with this when I see you in class.